Hello guys, so we're Group 6 and our project topic is understanding and visualizing crime incidents across New York State using knowledge graphs. So in this demo, we'll be walking through our system design, the ontology, backend setup, and the dashboard that users can explore. So we built it using RDF, OWL, GraphDB, Flask, React, and SparkQL. So the main introduction is that we are building a web page for and visualizing the NYPD crime data, and we use it. We do that using some of the tech stack that I previously mentioned. So our problem statement is that NYPD data sets are like large and difficult to analyze. So the data is really scattered and very inconsistent, and they're not semantic. So this kind of is like very makes it difficult to identify trends and patterns. So the solution that we went by is having an ontology-driven knowledge graph. This enables us to query and visualize by creating dashboards. So yeah, next, Utkarsh or Mitesh can go.
Thank you, Gautam. Okay, is my screen visible?
Yes.
Yep. Thank you. So this ontology model models the New York crime data using a structured semantic framework aligned with schema topology. That is, it's connected to a higher ontology, that's schema topology. It defines several major classes. In starting, that's crime event, a subclass of schema event, with more specific subclass such as shooting event and other crime events. The person class aligned with schema person includes the subclass victim, suspect, location, which is again aligned with the schema place. That includes crime location, plots, and other subclasses. The ontology also introduces a weapon class with subclass of firearm, knife, other weapons, which covers all kind of weapons used in the crime, and a time class that includes the time of day and year period, which contains the time at which the crime occurred. These classes are connected by object properties. Yeah. Object properties that describe relationships within a crime incident, like has victim and has suspect linked a crime event to the people involved. Occur that ties the event to a specific crime location. Use weapon specifies the weapon involved, which was involved. Has time indicates the time of the incident, and vice versa. So we also have data properties, data properties which capture the literal attributes such as incident ID, crime type, and occurrence date for events, which has age, sex, and race of the person who has committed the crime, the longitude, latitude of where the crime is committed, the name and the location, weapon list for the weapons, and the time label for the time titles. This ontology also includes instances which demonstrate how the model works in practice. All of these are integrated into a single shooting event. Individual that links the victim, suspect, location, weapon, and time, illustrating how the ontology represents real crime incidents in a clean, connected knowledge graph. So yeah, that was all about our ontology.
Pin, can you share your screen?
Yep. Busy.
Yeah, so this is Utkarsh, and I'm going to talk about the structure of our project, of how we have implemented it. So in the root directory, you can see there is API and web. So API handles the backend and the web controls the front end. In API folder, we have this app.py. So this is our main Flask server. It loads SparkQL queries, connects to GraphDB through the endpoint, which is defined in our .env file. Can you show the .env file? The second last in the root directory. Yeah, below that, yeah. So this is a GraphDB endpoint, which connects to the app.py. So also we have the requirements.txt file, which lists all the backend dependencies. Then we also have a queries folder, where each SparkQL query is stored separately in the form of .rq, which can be used to filter data according to what we want. So now I will go to the front end, which is the web folder. In web folder, this is our white-based React project. Under SRC, we store all the UI code. The components folder contains reusable visualization components like trend line chart, borrow bar chart, event list, trendline chart, and victim race chart. So now let's go to the app.jsx file. This file defines the main layout of the dashboard, bringing all the charts together into one interface. And then finally, for main.jsx, this serves as the entry point for the React application. It mounts the app component with the DOM and then initialize the front end. And we currently serve the development server on port 5174. The front end communicates with Flask through API calls, and in turn, Flask retrieves data from GraphDB using SparkQL. This was our project structure. So now Pin can talk about the web application and dashboards and queries.
Okay.
Thank you.
All right, now I will move on to the dashboard part of our presentation. Since our time is limited, I will show a few things just through screenshots. Just a few things. Okay, the first dashboard we're generating is the main work we have done. As you can see, we can use bar charts to show the number of crime events in different barrels, and we can use line chart to display crime trends across different years. Over here, you can zoom in for that. And for demographic information, such as victim race distribution, we use pie chart. And over here, we got a list of our crime events, and you can filter it by borough. As you can see, we got different borough in New York right now. And if we click on Brooklyn, it will search for it. And we got an API event calling for Brooklyn over here. Yep. And the second, because we implement the different feature of our work, we got a map, more graph and the crime list. And this one I'm showing is the crime and it's the graph and the crime list. And I can show the screenshot of more graph here. This is one with more graph to show that we can use our queries to do more things. And I can run the sample queries here. This one I have already done. It's for crime distribution across seasons and barrels. It separates the crime event counts by barrel names and seasons. And I will run on live for a different one. Okay, it always takes time. So I want to show the map of our, okay, I'll just, okay. Okay, our query is now generated. But it's, in total, we have 6 million of our crime events. So it's quite large. And now I want to have our simple queries of here. We designed a variety of queries to show different purpose. Yeah, okay. Okay, let's get back to, I still got something to show. No, this one. This is our turtle file with only 500 rows of data in the CSV file that I generated into a turtle file. You can see the properties over here and the values over subjects. Okay, go back to this. Yeah, it's generated. We can choose for the limits to change the total events we want to generate it, and close the heat map for mark clusters for precinct. We can choose different year, and it changes. As you can see over here, the events year equals to different one, limits equals to different one. You can choose for the crime type assault. When we zoom in and choose for one, you can see the data and the crime over here, and the crime name over here. Okay, that's all for our demo.
Oh, hi everyone. So I'm Siddharth, and this project has been a very collaborative experience for all of us. So I, Siddharth, have assisted in the debugging of any errors which had been occurring in the project, and have assisted in the documentation and coordinating with all the team members with the overall organization to keep the workflow smooth. So first of all, Gautam has worked on both the backend API and the development of the front-end integration. Mitesh has contributed to the ontology engineering and the data validation and ensuring the GraphDB imports the queries that have been worked very correctly. Utkarsh has led the front-end development in building the dashboard and the visual components. And at the last, Ping has led the backend development and assisted with the front-end integration of the SparkQL testing. So thank you all.
Thank you,
Yep.
everyone.
Thank you. Thank you.